Alright, so after that finishing that question, now let's jump back to the theoretical parts. Now the next point is about the running speed. So running speed, so what exactly is the speed? Speed was supposed to be like distance over time, right? So now suppose you are on a vehicle and you are going somewhere, right? Now let's imagine that for about 2 hours, two for about 2 hours you have been driving continuously without any stoppage, but after 2 hours, say you took about 15 minutes of break, fine, so you stopped the car. So you can see over here that when you consider the time only for the time accounting for the running time, the only time in which you were driving, you were you kept on moving, time in which you kept on moving, the time when you consider in calculating the speed is known as the running speed. Therefore you can say the running speed is equals to total distance you traveled, total distance divided by just the running time. Now if I talk about the journey speed, that means you also include the time you have rested. For example, in the running speed you will just observe the 2 hours time, you will not go with this 15 minutes laps. But for the journey speed you will say the journey speed will be equals to like total distance divided by total amount of time. The total amount of time will be equal to the running time plus stoppage, yeah, you also call it break time. Alright, so the next topic is like the density. So what exactly the density? So the density is defined as the number of vehicles occupying a given length of highway or a lane. So you're given an amount of lane, so you can also say that, let's try it first, the number of vehicles occupying a road of unit length at given instant. This point is important, at a given instant, and this is known as density. Alright, so how are you going to go with this? Like, you can take an aerial photograph of a length of a road, say X, for example, this is the road, and you took the photograph of it and you found that there are a number of vehicles like this. So you can say that the density, which is represented using the letter K, is equal to the number of vehicles, like over here it's 1 2 3 4 5, equal to 5 divided by the length of this road, say this is x kilometers, 5 divided by x, 5 divided by x, so your density. So I can call it like n vehicles x distance, so you get the unit as vehicles per kilometer, you consider the kilometer. So the x is the length of the road and the n is the number of vehicles. So this was the density. Now if you need to calculate the so-called running speeds, journey speeds, or the delays in the traffic, then you need to understand the speed delay studies. You need to go through these studies. So there are a number of methods that are used, like you can make any observer stand over there to see what's the speed of the cars and all. Point-to-point observation is one of the methods. I can call it like standing observers method. Standing observer method is just standing over there and looking at it, and you can even make it like elevated. You can go to some higher grounds and then watch the road that is passing by it and see that what is speed of the things, and whatever the study you want to calculate, do on these things you can do. Another way is for the license plate method. License plate method, in which the license plate is observed or noted down of any vehicle, and when it is again seen, you can calculate speed and all, the distance covered by it, the amount of time it took to reappear. You can calculate the speed. There are some methods, just a few of them, and you can even ask some people, like I can call it interview method. All right, that what was your speed and how you like moving and all. Now there is one more way in which if there is like a traffic like this going on, fine. So there are cars moving over here, fine. So what we do, we take one car as an observing car. It keeps on moving alongside the other vehicles, and we call it the floating car. And using this we calculate the, what do you say, speed and all the characteristics that we have understood right now. Density also can be calculated using this. So we can calculate the flow and speed and density. Flow, speed and density can be calculated simultaneously using this floating car method. Fine. This floating car method is also known as the moving observer method. So the other name for this is floating car. So if we understand about this, then it is used, the aim of this experiment is to determine the running and journey speeds, to determine the running and journey speeds. Alright, so in this method, just listen to it. In this method, the speed and the flow can be obtained by traveling in a car against and with the flow. Like I just gave you an example, that is, the traffic is moving like this, fine, and you are in the car. I'm denoting it with a different color. Over here you are in the car and you are just moving with the traffic flow, whatever. So it can be obtained by traveling in a car against and with the flow and noting down the journey time. You can all do is like calculate journey time. Later on you can convert it into speeds, and you can even calculate the number of vehicles that you have overtaken, fine. Okay, and this floating car, this is the floating car, and number of the vehicles that you have overtaken, or the number of vehicles that overtakes you, even you can calculate those things. And if you go like this and just take a turn over here, and now you move in opposite direction of this flow, then you can see that the number of vehicles that you met when you are in opposite direction, all these variables you can use to calculate the various what you say, speed, flow and density. So that's the moving observer method over here. Now you can define some parameters in it. So like if I say that TW, alright, it is time taken by the vehicle when it is moving with the stream, like it is going from here to here. So how much amount of time is taken as TW. W represents the with the stream. Now if I go against the stream, I will call it TA. So the time taken by the vehicle when going against the stream. Alright, so now you can see all these times are covered. So there will be like number of vehicles which overtook us. Okay. As I told you, then there can be some vehicles that can overtake us. We are just a floating car, testing car. So that the number of vehicles that overtook us is represented by NO, and NP is like number of vehicles which we overtake. So number of vehicles overtaken by us. Overtaken by us. It is represented by NP, and there's one more term like NW. It is number of vehicles moving with the stream. Moving with the stream. It is nothing but equals to number of vehicles that has overtaken us minus number of vehicles that we have overtaken. So from here I can say that NW is equals to NO minus NP. This is just a small thing. And NA is the number of vehicles moving against the stream. Moving against the stream. So these are some parameters, or you can say things that we can see while we are in the floating car, and using these things or parameters I can calculate out the flow and the average speed. Formula for the flow is given as NW plus NA divided by TW plus TA. So this is the formula for flow. As I already told you that NW is NO minus NP, so this is that NW. And you can also say that velocity Vs is equal to the length that we have covered divided by TW minus NW divided by Q that we have just calculated here. So this is one way. And if we want to calculate the density also from here, then we can use a relationship that Q equals to K times Vs. So here K is the density. So using this moving observer method, we can calculate the values of flow, the velocity, average velocity, and the density. So if suppose you are moving on a road, and on a road you see a different type of vehicles, obviously there will be some bikes, there will be some car, trucks and all. And what is different between a bike and a car is in their dimensions. The bike is much smaller and the car is much bigger. If I get some trucks over here, then it will be bigger than the car. So the changes in the dimensions, that is, I can call it directly as size. So there is a factor of size involved when we are designing or looking at the highways. So the bike is covering the lesser, what we say, area or the position or the region in the highway. So it is creating less amount of congestion, or the cause of the traffic jam, we call it, is more due to the trucks and cars rather than just bikes. It's a known fact. Now for example, what if I call in mid the highway, what do you say, bullock carts? Their size are huge, literally they are huge size, and there's, if I say that size are massive and their speed is much lesser. The speed is much lesser as compared to the bike, car and even trucks. So I need to understand that for designing of a highway and understanding its flow and speed characteristics, I need to understand that the vehicles must be looked upon using two of these characteristics like size and speed. Based on these things, there should be some universal unit for these so-called vehicles. So if I convert all the vehicles into some single homogeneous unit, then that particular homogeneous unit is what we called PCU factor. Now this PCU stands for passenger car unit. Now you can understand it like this. If I say a car is taking 1 unit space, or according to its speed and dimensions, 1 unit in some road, 1 unit, it's just a unit, homogeneous unit, then I can say that the bike is just taking about half of the unit that is been covered by the car. Alright, now what if I call in the bus or the truck? Then I can say these are some of the values. So values given by IRC. So these are that for the bus we take the unit as 3. That what this actually means is that one bus is equivalent to 3 cars, and the 1 car is equivalent to 2 bikes. So this is how we divide each and every vehicle with its passenger car units. So these units are known as PCUs, or passenger car units. And now I talked about the bullock cart. Its unit lies from 6 to 8 units. It's a huge thing. Not only the size is the matter over here, even the speed. If the thing is more slower than the vehicles moving behind that thing, which is moving already slow, will make all the cars or the bikes that have capability of getting more amount of speed to move in the forced less speed condition. So that means this bullock cart must be considering the factor of size as well as speed also. That's why such things are given much higher value of the PCUs. This represents that a bullock cart is equivalent to about 6 cars or even 8 cars moving at a time in the road. So it will be causing much more amount of traffic jam congestions in between. But the bike is having, like, you can call it 0.5 unit only. So these are like the PCU factors. Alright, so now if I talk about something like what I told you in the beginning, that there were some fundamental traffic characteristics. Those fundamental traffic characteristics were, you already know, like flow, speed, and density. We have talked about them till now, right? So now using these parameters, I can derive some of the other parameters, and they are known as the derived characteristics from these things only. These are fundamentals, so I can get out some derived characteristics, which are also known as microscopic characteristics, microscopic and macroscopic. So they are the derived characteristics of traffic. So the first concept that comes is the headway. Headway is like the distances between the two vehicles moving. So they are subdivided into, one is the time headway and another one is the space headway. Now let's understand what is the time headway. So difference in time, for example, there is a road and there are two vehicles. They are separated by some distance, that I agree, but with respect to time also they are separated. So I can say that after 2 seconds, if this stops, then after 2 seconds this will come to here. So the distance, you can't only determine the gap between the two vehicles by the distance, but also by the time. So this is known as a time headway. So in theory, if you will write, it will be like difference in time between successive vehicles. Alright, so its unit is like seconds per vehicles. Now the thing that is needed to be understood over here is this is nothing but this is traffic flows inverse. If I take out the inverse of traffic flow, that was, if you remember, traffic flow was like vehicles per hour. I calculated it like this. So if I take the inverse of this vehicles per hour, I will get what is the seconds per vehicle. So from dimensionally also and from conceptually also, you can understand that this traffic flows inverse is equivalent to the time headway. Alright, so now let's jump to this space headway. Now this is much clearer and logical to you, that if there is the road and one vehicle is like this, or is like this, the gap between them is what is the space headway. So I can call it that the difference in space between successive vehicles is called space headway. Now the unit that are important over here is considered as meters per vehicle. Now you already know that the inverse of this meters per vehicle is vehicles per meter, and I know this is nothing but a density. So I will call that the inverse of density is nothing but equal to space headway. Fine. So this was about it. Now let's jump to the another topic, that is the arrival of vehicles. Now I want to predict that what will be the arrival of the vehicles coming, and like for example, like I have a question that find the probability that you will observe 0 vehicles in 8 seconds in any road. Like you need to find the probability of that this thing happening. So now let's see what I just said, that I need to find the probability that we will observe 0 vehicles in 8 seconds. Alright, where the flow is given to you like 900 vehicles per hour. This is given to you. Now you need to calculate this probability. So for this probability thing, we use so-called Poisson's distribution. Poisson distribution. Now what this is like the probability of x is equal to, the formulation is like this: mu to the power x e to the power minus mu divided by x factorial. Now to solve this question, first we need to find the flow rate per time t. Flow rate per time, say over here it's 8 seconds. So it will be like the flow rate is 900, and if you multiply it with the 8 seconds, so you convert it into hours, it's 3600. This will come out to be 2 vehicles. So in 8 seconds 2 vehicles are passing currently. Alright, so what is the probability that in 8 seconds there will be none of the vehicle will pass? So that's we can calculate using this. So what will we do, that we will substitute the x as 0, because we need to find the probability as 0, and the flow rate is given as 2. Alright, so we don't need to be considering that time thing, because we already included in to calculate the 2. So this p0 will, when you will substitute these values in it, x0 and this, you will get it like 0.135. So this is the required probability that in the 8 seconds that 0 vehicles will pass, even though you know that the rate flow per time 8 seconds, every 8 seconds 2 vehicles must pass according to this flow. But probability wise, it's like you can say it's 13.5% the surety that no vehicles will pass in 8 second time. So such studies are done in the arrival of vehicles using the Poisson distribution. Okay. So now in this relations of traffic flow, we will consider the graphs relationships, how they vary and do other things like relationship between flow and speed. This is the first concern. The speed is like with Vs and the flow is with Q. Now at initial point, the value of flow will be 0 in two conditions. Either when then there is no vehicle, alright, and the other condition is like they are too many vehicles that they cannot move. So I'm considering 2 points, one over here and one over here. Alright, so in this the speed will be maximum and this should be like this. Now if I go at the maximum flow, at some point this should be the maximum flow. Fine. The speed will be between 0 and free flow speed. So this is like Vf, I call it the free flow speed. It will, at this speed the vehicles will just keep on passing, they will not pause or do anything. So at this free flow speed there is no congestion and there is no flow formed, therefore the value of it is 0 over here. So I can say that flow is 0 either because there is no vehicle, that is at over here, or there are so many vehicles that they cannot move. That's it. Because they cannot move, therefore the speed of that is 0, and since there is no vehicle over there, so they are following the condition of free flow speed. Any vehicle can come and go at the recommended speed with no restriction at all. So I'm taking that point is over here Vf, and this is like initial point V0, I can say it. And the maximum flow condition will be somewhere happening in center, and its value will be somewhere between the speeds of 0 and maximum, because the speed cannot exceed the free flow speed. So I will get a curve like a semicircle like this. So over here will be the maximum flow, and this maximum flow will be at the speeds of between the V0, that is there's no speed at all, and at the free flow speed. So it will be lying somewhere between, because it cannot exceed the value of this and cannot go bit below this value also. So it will form a curve like this, and it's not exactly a semicircle, it can be a parabolic thing. And this is what we are gonna get. So it will be a parabolic obviously, but I've shown here like this a semicircle, it is parabolic, and this value is known as Q max. Alright. Now let's go to the another relation which can be formed between the flow and the density. Now over here I'm taking density and the x-axis, and the so-called flow I'm taking it over here. Fine. So what I will see here is that when the density is 0, alright, the flow will also be 0, since there is no vehicle on the road. So I will get that point over here, and the number of vehicles that will gradually increase, the density as well, the flow increases. Fine. So I can say it like this, it will keep on increasing. Yeah, it's making sense. Now when more and more vehicles are added, it reaches a situation where vehicles cannot move. Now check it. This refers as a jam density. Now when the vehicles cannot move again, you can say that you are coming up to here, somewhere over here you can say. So this density where the now vehicles cannot move, it started increasing, and it slowly decreases because at start there are no vehicles, so there is no density, no flow, nothing. But as soon as the vehicle starts coming, then the flow increases, density also increases, it reaches up to some maximum point. After that the congestion increases on the road, and so the flow decreases as the density still keeps on increasing, and a point is reached when the flow is just again zero, but the density is kind of maximum over here. So this density is known as jam density. I can call it like K jam. Alright. Okay, and since the vehicles cannot move in this jam velocity, therefore the flow value is again zero over here. Okay, and there will be some density between 0 and jam density, and over here I can say where the value of flow will be maximum. Alright, so I can call it again that Qmax. Alright, so I can just say that with Qmax at the time the density is K naught. So that's how it's gonna vary. Now one more relationship is there between, I can say, speed and density. If I talk about speed and density, let's take density again over here and speed over here. This is at a y-axis, this is at a z-axis. Alright, so when the speed will be maximum, then the density is 0, obviously. If speed is maximum, then there is no, you cannot calculate density because all the traffic is just going, it's not being staying in at a particular section, so density is like 0. So, and this speed itself is known as, I've discussed this before also, VF, the free flow speed. Alright, so and at the jam density we just saw that Kj value, that's maximum density, Kj, I call it Kjam. So at that time also at that time the speed will be 0 because there will be no motion between the cars and almost anything. So there, this represents a straight line, that's a linear relationship, there is no parabola involved over here. So I can show it like this. So this is the graph between speed and density, and that's all there is for the relations for the traffic flow. Now if you want some mathematical relations, I can give it to you for the use of in the GATE exam. Like if you need to calculate the velocity and you know the free flow velocity, and you can use it to calculate other variables like 1 minus k divided by kj. Alright, and this q, I've already told you before, is equals to k times velocity. Simple. Q is the flow, this is the velocity, this is the density, and the k max is some equal to k jam by 2. Alright, and this, what is this k max? This thing. I want to say this k naught. K naught is equals to kj, this kj is this k jam by 2. That means this is just at the middle of this line over here. Alright, so if I say speed, V naught is equals to free flow speed by 2, everything becomes half if you go at the center point. Then from here I can say that q max is equals to k times v, I call it j, and this is free flow, so I call it F divided by, there are two 2's, I'm just multiplying these two things to get Q max equals to 4. So these are some weird relationships for the relations of traffic flow. So the important thing is to understand the graph and some of these relationships. Okay, before we come to this level of service, let's understand one more term, that is the capacity. What is capacity? Capacity is the maximum flow, which is like Q max. It is known as capacity. Now it is affected by the factors. Some of the factors are like, what is the width of the lane? I call it a lane width. And what are the different varieties of vehicles that are passing through? I can call it like composition of vehicles. Fine. And what are the alignment, the curves and all things? I can just call it alignments of roads. In geometric design we will understand it much deeper what they really means, but for now it's fine. Alright, so this was the capacity thing, and this capacity, or you can call it capacity, is nothing but inverse of minimum average headway, because this capacity is nothing but Q max, so its inverse will give me minimum average headway. That's all it needs to be understood about it. That's it. This was capacity. Now let's come to this level of service. So from the speed flow graph, that graph, it was like this. If I say this was the speed and this was the flow, I was getting 2 times flow, the 0 points. Fine. So at, and there was a maximum point, and it was going like this, and like this it was coming. Fine. So I said this was like V0. Okay, this V0 was corresponding the maximum flow, I call it like Q max. Fine. And this was a free flow, VF. That's it. So according to this speed flow graph, level of service is determined. That is, that how easily are we able to, what is this level of service? It is how easily are we able to travel. It is determined by this. Okay, and this ranges from A to F. Alright, and this is according to the highway capacity manual, so you can't debate about it. It is based on the volume capacity ratio. Alright, and can be represented using this speed flow graph. So if I make some segments out of it, I can say this part, initial part, this part is for A. Now we will understand what these A, B and all these things are, but let's first categorize them. Now let's go with this. This part is like for B. Alright, and let's go with this part. This part is for C, and say this part is for D, and again let's come to here. This part is for E, and the final part is for. Alright, so A, if I talk about A, in this types of road we travel very freely. Okay, and in freely that means we are close to our max speed, close to max speed. For the lane service B, we say it's little free, but from here that freeness decreases. Okay, up to the point of F where there is a jam-packed situation. Alright, so you can see that in the section A, this value of speed is much higher. So over here there is no restriction, you can just flow it out, and value of flow is also less. In B, you see the speed is coming less and the values of the flow is coming more, so there is little less freeness. In C, when we come down, then we see that the speed has been reduced substantially and the flow is increasing, so a jam condition is going to happen very soon. And at last at F, when there is no speed, that is there are too many cars or something like that, and you can't move, there's jam condition and all, so your flow is also not happening, so that is like F. That is known as jam-packed situation. That's all related to this level of service. All right. Now, before we come to this accident and parking studies, let's understand one thing more. That is, what is theoretical maximum capacity? Now, this can be calculated. Now, this can be calculated for single lane, like C is equal to, this is a formula, 1000 times V over S, and the unit is like vehicles per lane per H. Now, what are these things? So, this V is the speed, and that too in kilometers per hour. Alright, and that S is the average center to center spacing of vehicles. Alright, now let's discuss two questions that came in GATE 2006 and 2012. Then after that we will dive into that accident in parking studies. You will understand some of the symbols that are used, and then you will go for traffic signals and other like rotary and all those things. Alright. So this is the question that came in GATE 2006. So what it is saying is, on an urban road, free mean speed was 70 kilometers per hour, and this free mean speed is given by this USF over here. Alright, and average spacing between vehicles under jam condition is 7 meters. Alright, it is just a spacing given to you. Alright, you don't know this jam density. What all things are given? This is one of the relationship that has been given, and this is another relationship. So you have already seen this. We have just seen this in the last relation things. Alright, so this is U equals to USF and 1 minus K over Kj, where K is a simple density and Kj is a jam density. USF is the free mean speed, U is the space mean speed. Alright, so how to attempt this question? For this you need to calculate the Umax. You can directly go for the part that I derived over here. So not I derived, just gave you the relationship as it is. That this one. That Qmax is equals to Kj dot Vf over 4. So if you want to use, you can use this formula like Kj. Just see this. What is written over there? This is Vf. Alright, so Vf into Kj by 4. Okay, so I can use it like Qmax equals to Vf into Kj by 4. This was the formula given. Alright, so this Vf is nothing but your free mean speed. You can over here USF. This is Kj by 4. Now you will be considering the what is this Kj. Now you are given with the average spacing under the jam condition, which is like 7 meters. So to calculate the density out, it is the, you can write it like this, jam density is what it is. It is the number of vehicles in 1 kilometer length. That is, if I want to calculate the jam density for the space headway of 7 meter, I would calculate it like the 1 kilometer converted to meters form divided by 7. It is also in a meter, and I will get it like 142.86 vehicles per kilometer. Alright, so this is something that is jam density. This is how we are gonna calculate it. So I can just directly place its value in form of Kj, and I already know USF. I can calculate the things. So USF is given as 70 in question, and the Kj is 1000 by 7, and there is another 4 over here. If you solve it, you will get it like 2500 vehicles per hour. This is like a Qmax. This is what you need to calculate. But you must understand this, that how are we getting this formula. So I already told you that it was like K equals to Kj by 2 and all those stuff. So now let's derive kind of thing how to get these formula. You are given these two things. Alright, now this was the equations that we were given. These were the equations that we were given. Now you can say that Q equals to UK from here. In place of U, you can place this value like USF 1 minus K over Kj multiplied by K equals to this. You can get this. Alright. Now you need to find the maximum Q. So for the maximum flow, you need to calculate dq by dk equals to 0. Alright. So you can differentiate it, and when you will differentiate, you will get USF as it is. K will come inside, so it will be again 1 minus this K will come inside, will form K square. Kj is a constant, so it will be like 1 upon Kj, and K square differentiation will be like 2K, and then everything equal to 0. So from here you will gather the information like 1 minus 2K over Kj is equals to 0, and then from here you will get the relationship as K equals to Kj by 2. Alright, so if you put this value back to here and also over here, you will get it like Q equals to, and this is now Q max because you're placing the value of K as Kj by 2, which was derived using the K max condition. So this Q max is equal to USF as it is 1 minus Kj by 2 divided by Kj. Outside also there will be Kj by 2. After solving it, you will get USF multiplied by Kj divided by 4. So this was how this equation was derived. You can directly just remember this as I remembered before. To calculate the answer, you will get the same answer, of course. So this question came in 2006. So in this question also came in GATE. It came in GATE 2012. So in this question, a 2-lane urban road with one-way traffic has a maximum capacity of 1800 vehicles per hour. Under the jam condition, the average length occupied by the vehicle is 5 meters. Alright, that's fine. The speed versus density relationship is linear. Alright. For a traffic volume of this, the density you have to find. Alright. So in order to attempt this question, we need to understand what are the things that we are given with and how can we utilize them. So we know one thing that I just gave you one formula, that maximum capacity, I use the term for it like C equals to 1000 V over S. Alright. So what was this? It was nothing but C is the maximum capacity. Alright. And it is same as the flow. So over here the flow, yeah, the maximum capacity is given as 1800 equal to 1000, and you don't know the V, that's the velocity of the vehicle's average velocity, divided by S, and the S over here is the average length of a vehicle. S is average length of a vehicle. So this S is representing the length of a vehicle, and over here it is given as 5 meter. So I will use it as 5. And from here the value of V is coming out to be 9 kilometers per hour. Alright. Okay. And we know this, that this velocity is nothing but equal to V free divided by 2. So from here V free space, V free flow velocity, Vf is equals to 2 times V, and that is 18 kilometers per hour. Alright, that makes sense. Now we know one more formula, that this max C, that is, you can also call it Q max, maximum flow, is equals to 1 upon 4 Kj times Vf. Alright. So this thing, that is Kj, you can calculate it out using this. So how are you going to calculate? Qmax is given as 1800 and it's 1.2 Kj, and Vf you have just calculated as 18. So and this is like sorry, 1 upon 4, this was 1 upon 4. So kj is coming out to be 1800 into 4 over 18. It is 400 vehicles per kilometer. So I got the jam density over here. Now in question it is given then if q is equals to 1000 vehicles per hour, then what is the density? I knew that this thing, so I can do something with it. I know one thing that you can call it u, or you can call it q, is equals to k times that we got as vf, alright, that is this thing vf multiplied by 1 minus k over kg. We know this thing. From here the q is given as 1000 and this k we don't know, we need to find it out. Vf is given as 18, we just calculated it. 1 minus k we have to find out, and kj came out to be 400. So from here the quadratic equation will be formed like 18k square minus 7200k plus it's 4, and then there will be 5 zeros equals to 0. If you will solve this quadratic equation, the value of k that you are going to get will be either 66.67 or it will be 333.33. Now you need to consider only one of these two values. In the options that were given were A 52, B was 58, C was 66, D was 75. So after seeing the options you can directly take that yeah, it's 66. But if you want surety, if it's like a fill in the blank question, then you need to be sure which value you need to use. So for this you need to go for the flow versus density diagram. So what was that? Density was taken over here and the flow was taken, you can call it Q, was taken from here, and this graph was like this. Alright, so I told you that if density is 0, the flow will be 0, then if density start increasing, the flow will increase. At the time will come when it is maximum, then again density will increase but flow will decrease. At the time come will there will jam, I call it kj. So this was kj, and I told you that when there was a qmax system, qmax flow was maximum at that time, this was k naught. I told you that k naught will be nothing but kj by 2, right? And your value of k is coming to be like qmax is 1800, right? And you are calculating q for lesser value, it's like q equals to 1000. So for that the value should be k, the new k that you're calculating, which is corresponding to q, must be less than kj by 2. kj by 2 is this thing, alright, this is kj by 2, it should be less than this only then, because for 1800 the value is coming k naught, for 1000 the value corresponding this graph will be lesser than kj by 2. So for the value of k less than kj by 2, it's only one way, it is 66.67. Therefore C is the final answer.